So y equals ax to the n. So if you could just write that down, that is our starting point for case scenario 1. Now, what are we going to do? We're going to take logs on both sides. So log y equals log ax to the n. So what I might do, I'll see what the lag's like. It might be worth me just pointing with a fluorescent pen if the lag's not going to be painful. Nope, that's taking a while. That is a painful lag, so we will ignore that. So logging both sides, we get log y equals log ax to the n. And then we use the multiplication law. So our right-hand side breaks down to being log a plus log x to the n. And that's where I've got line number 2 written down. Ignore that red bit now. I'm not going to do that. I'm not going to do that. I'm highlighting because it's just too much of a lag. We then use the power law. Okay, so log y is still on the left-hand side equals log a plus n log x. Now, what I want to then do, I just want you to rewrite that right-hand side the other way around. So rather than log a plus n log x, can you write down n log x plus log a? And we've now got that into y equals mx plus c format. Okay, our y-axis is log y. That's the bit I've done in green fluorescent pen. So note the left-hand side at the top is our y-axis at the bottom. Okay, log y. And looking at where I've written it on blue on the right-hand side, n is actually our gradient, is our m. Log x is our x-axis. So note the bits I have fluorescent penned in yellow. Okay, so our x-axis is log x. And following the fact that it's y equals mx plus c, our intercept on the y-axis is the bit that I've highlighted in pinky purple. That is our y-intercept. Okay, so what we can go and conclude from this case 1 scenario, our x-axis is the log x, our y-axis is our log y, the y-intercept is log a, and the gradient is n. So it's just a way of writing out, of creating a straight line graph from initial point where you've sort of got an exponential graph. And so this will be sort of cropping up in science. So that is case 1. Is there anybody, as there's quite a lag here, and I haven't been able to highlight it, is anybody who'd like me just to go over any of those steps again? It's important, I think, that you understand how we go from case 1 at the top, y equals ax to the power of n, and you could work through those steps and just recreate the graph at the bottom, and you understand why the x-axis is log x, you understand why the y-axis is log y, you understand why the y-intercept, c, is log a, and you understand why the gradient is n. Is there anybody who'd just like me to run over that again? Okay. So that is case 1. All right, so just note what case 1 was. Our x there was the thing that was had the power against it. It was y equals ax to the n. Now with case number 2, x actually becomes the power. So I'm going to leave the example, just going to go through to case 2. No doubt there's going to be a bit of a lag. Oh, not too bad. There we go. So please note a different starting point here. Okay, y is now equaling ab to the power of x. So x is no longer what is being powered. X is the power itself. Okay, now it's just a similar exercise. You just got to take your time, work your way through and just convert it into a y equals mx plus c scenario. So we've started off by taking logs on both sides. So log y equals log ab to the x. That's the line which I called line number 1. We've then split the right-hand side down into 2 terms using the multiplication law. And then line 3, we've used the power law to take x to the front. Okay, and then over on the right-hand side, you'll see that I've then in blue gone and just changed the right-hand side order. So it now becomes into the y equals mx plus c order. Okay, So what are we saying here? Our y-axis is now log y, as it was before, I think. Our x-axis is now just x. It's just x. All right, it's not log x, it is x. With this case 2 scenario, our y-intercept c is log a. I think that was as before. Can't quite remember off the top of my head. Okay, and our gradient now, our m is log b. So it's another case where you've got an exponential graph to start with, and it's just that x is a different part of that. Go and turn it into y equals mx plus c using the log laws, and it's then just easier to analyze. You can analyze the data using your understanding of gradients and what have you. So that's the basics of this, guys. So I want us to work through the question. I don't think there's a need for us to go through the examples. I think I'd rather you just launched into it. So for exercise 14H, let me remind myself how many questions. Well, it's 6, 7, I think, wasn't there? 7, 8. Oh, a few more than I remembered. Eight questions. 9 questions, excuse me. So 9 questions there. So if we could be working through those. I'm not overly worried about spending too much time on the ones where you've got to draw the graphs, okay? Because obviously we're going to be, graph paper is going to be hard to come by. So let's just really focus our time on those where we're not having to plot. So probably leaving out 4, 5, and 6, okay? And 3. All right, so if we can just focus now on doing questions 1 and 2, maybe I'll just show you the slides for 3, 4, 5, and 6 as you get there. Okay, and then just go over and do questions 7, 8, and 9. 2 lessons to do this. Okay, and any spare time, please can you just dot around the mixed exercise. Okay, and then that will be it on Pure. We'll be able to move on and do something else with me. Okay, guys, I'll stop the recording now. So if you could just start working through those questions, and obviously I'm here for the rest of the hour to help you if you get stuck.